Today we discussed about the projection of points in unit 1. In projection of points, distance from HP, distance from VP. The first quadrant above HP in front of VP rules elevation above XY, plan below XY. Position of points, elevation, plan. First one above HP, below XY, plan no. Below HP, elevation below XY, no plan. In front of VP, elevation nil, plan XY. Behind the VP, elevation nil, plan above XY. The important observations: the distance of plan from XY, distance equal to distance of point from VP. The distance of elevations from XY equal to distance of point from HP. Projection lines are perpendicular to XY. Line parallel to HP. Line parallel to HP. The true length seen in the both elevation, both view parallel to XY. Case 2, the line parallel to HP, inclined VP. True length seen in the plan, elevation appear shortened length. Line parallel to VP, inclined to HP. The true length seen in elevation. Plan appears shortened. Next one is a line inclined both plans, the tricky parts. This method is the most difficult and important topics. A line inclined to both HP and VP will not show the true length of plan, not showing the true length in elevation. Both views will be apparent length. Theta equal to inclined HP, inclined VP, true length is equal to actual length of line. Apparent line equal to shortened projection. Why both view are shortened? Because the line is tilted in 3D space. It sloping upward or downward conditions. Sloping sideways, so neither projection plan see the line completely flat. Next one is a step-by-step method, that means a rotation method. Assuming the line in parallel to VP, inclined to HP, draw the true length in elevation corresponding plan. Now incline the line to VP, rotate the plan given angle, project the